Hi, welcome to another lesson at EDU Solutions Institute. Now, on today's lesson, we are continuing on the CSEC physics syllabus, where last week we learned about work and energy, where we looked at what is work, what is energy, and the types of energy that exist at this level. Now, in today's lesson, we're going to explore about power and efficiency. So stay tuned as we look at the concept of power and efficiency. Now, what does power mean? Now, we learned last week that work is how much force or the effect of a force that causes an object to move. And we learned that energy is the ability to do work. So in power, power is based on work, is the rate at which work is done. And the word rate determines that is how fast do we do work, which means that we're dividing by time. So in that case, it's how much work is being done in a specific time period that gives us the power. Or if we're looking at energy, it's how fast do we change one energy form into another. So therefore, we can use any of these definitions based on the situation of the power that you're experiencing. So we can say that power is work over time or energy over time. And we know that the unit of power would be watt, which is a capital W. Now, if we explore the concept of power in terms of a bulb, so we buy a 60 watt bulb. What exactly does this mean? Right? Now, a 60 watt bulb, what it means is we're going to think of it as being 100% efficient. And in this case, what it means is that it will take 60 joules of electrical energy and convert it to 60 joules of light energy in 1 second. So that's what the principle or concept of power is. So when we have a power number, it is telling us if it's something that deals with energy, it tells us that this is the amount of energy it's going to be used to convert it to another energy in 1 second. So therefore, for a light bulb, if it's 100% efficient, then it will take 60 joules of that energy, electrical energy, and convert it to light energy in 1 second. But the thing is, nothing is 100% efficient. So therefore, when we do buy a bulb that is 60 watts, what it is doing is that it takes 60 joules of electrical energy, but instead of converting it to 60 joules of light, it possibly will give you 40 joules of light, and then the 20 joules will be lost as heat, right? So therefore, you're not getting how much you're using to get what you want. So therefore, that's where we lead into efficiency. And efficiency tells us how well does an object or device does the work based on how much energy it uses. So therefore, we find efficiency by what's the useful output. So in the simple case here, we said that instead of 60, it was 40 joules of light it produced. Then the useful output would be 40, because a bulb will only useful when it gives light. So it's 40, and the input would have been 60, multiplied by 100, right? So therefore, we will get that it is unit would be percentage. So therefore, if we say that something is 80% efficient, then that means it's going to use 80% of what is given to give what it wants, and then 20% of it is lost as waste. So on the concept of efficiency, nothing on earth is 100% efficient, but we try to make things close to being efficient so it doesn't have a lot of waste being produced, and hence you will get more from what you're being using. Right? So therefore, remember, we're using what is useful output over the input. Right? So if our input is 60, is how best we can create a bulb that will make useful output as close to 60 as possible. So that's the reason why the development of the light bulb is so important, that it has now reached to a point where we use LED bulbs, because LED bulbs reduces the heat that it's produced, so hence it will create more light than heat, so hence it brings up the efficiency of these bulbs. So that's the principle of power and efficiency. So I hope you understand a little on these concepts. On next week's lesson, we will be using these formulas and formulas from last week into some practical examples. So stay tuned as we explore more on our CSEC physics syllabus.